Welcome to 75 Day Hard Generative AI Learning Challenge, and it's day one. In this video, let's break down what Manus team learned while building AI agents. In a high level, when you want to build an AI agent, you can take two main paths. First one is you can train or fine tune your own large language model, and the second one you can use the existing models like GPT, Claude, and control its behavior through all the prompts and tools. Manus team choose the second path mainly because of two reasons. First one is faster iteration, like training a large language model can take weeks or months, but you can change prompt or its context in a few minutes. And also, second one, model agnostic, which means like you will not depend heavily on one model. So Manus team can switch to newer models when they come out. Now let's see the core principles of context engineering. First one is designing around the key cache. All the modern LLMs uses something called key value cache, also known as key cache, because it saves the computations from earlier parts of the conversation, so that the model don't have to compute everything each time. But for that to work well, your context must be stable. So even a tiny change like adding a timestamp or changing a white space can break the cache and make the model recompute everything from scratch. To avoid this, Manus team follows two main rules. Like first one is keep your prefix stable. So means you don't put any changing text like dates or random strings in the beginning of the prompt, and use the append only context. Means always add the new observations or the actions at the end of the context instead of editing the old ones. These rules makes the agent to run faster and cheaper. Coming to second one, mask tools instead of removing them. When you want to build an agent, you often give access to many tools, and you think like it will make the agent smarter. But as the tool count explodes, the agent is more likely to select the wrong tool or like a take inefficient path, and this will makes the agent dumber instead of smarter. So you want to temporarily hide some of the tools and dynamically update the tools might improve the intelligence, but this will break the prompt cache and also confuse the model. So Manus teams uses something called masking, which means the tools stay in context, but the model is told to those tools are currently unavailable. This makes the context stable and preserves the cache efficiently and prevents the model from hallucinating from missing tools. To third one, use a file system as a external memory. Even though the modern LLMs supports million plus tokens, but the model performance tend to degrade beyond certain context length. Even the technical window supports it. So instead of keeping everything inside the prompt, Manus team gives an agent a file system, basically long-term memory outside the model, and agent can write important information into these files and read back when they need it. For example, instead of keeping old meeting notes inside the context or like whole web content inside the context, the model can write to external file system and load when they need it by just keeping the reference to it. This approach keeps the context small and efficient and allows restoring the old information later. And this will give the agent a structured, persistent memory system, which improves the model performance. Coming to fourth one, remind the model what's important. Generally, large language models pay attention to recent tokens. So if your agent main goal written back far in the context, it might be get ignored. So Manas team solves this issue by having the agent to regularly rewrite its task list. For example, updating the to-do file or summarizing the next steps at the end of the prompt. So by bringing the important goals to the more model recent attention window, the agent stay focused on what matters the most. Coming to fifth point, keep mistakes inside the context. It's always tempting to clean up the context or delete the mistakes or failed actions, but Manas team found it's actually better to keep them inside the context. So when model sees its own past mistakes or the outcomes, it won't try to repeat them. So this will act as a self-correcting loop, and the model learn what went wrong and adjust its future actions. Coming to sixth point, avoid too many repetitive examples. When we add a few short examples to teach the model, we generally use the similar examples for consistency, but too many identical examples may cause the model to follow those patterns blindly, and this will keep the model uh, like overfitting to a specific pattern, and like this makes the model not to work well for a general purpose. So to avoid that, we can keep the all the examples general and avoid like a specific examples. Yeah, thanks for watching. See you in the next video. So these are all the 6 points Manas team discussed in the blog.